So here is a question from Cambridge Examination Paper 1. Express 2x square plus 16x plus 5 is equal to 0 in the form a times x plus b whole square plus c is equal to 0, where a, b and c are constant. If you can solve this question right now confidently without hesitation, you can skip this video. But if you looked at it and felt unsure where to start, then this video is for you. By the end of this video, this question will feel very straightforward to solve. Today we are going to cover three things. The first method is called factorization method. Then we have perfect square method. Then we will learn how to use discriminant formula. So method 1 is factorization. This is the fastest method when it works, and Cambridge will always give you a quadratic that factorizes cleanly if they expect you to use this method. So in this method we are going to discuss two cases. So case 1, when a is equal to 1. What do I mean by this? So the general form of a quadratic equation is ax square plus bx plus c is equal to 0, and we are considering our first case in which a is equal to 1, which means we have equation of the form x square plus bx plus c is equal to 0. In this case, the coefficient of x square is 1. So let's start with this example. X square plus 5x plus 6 is equal to 0. In this case, I want to find two numbers, let's say m and n, which add up to the middle term, the coefficient of the middle term 5, and the product of these two numbers m and n is same as the product of coefficient of x square 1 and the constant part in our quadratic 6, that is 6. So I want to find two numbers which add up to 5, and the product of two such numbers should be 6. Clearly, two such numbers are 2 and 3. I can see that 2 and 3 add up to 5, and the product of 2 times 3 is equal to 6. This means I can rewrite my quadratic equation middle term as 2x plus 3x without changing my quadratic equation, since 2x plus 3x will add up to 5 only, 5x. Now from the first two terms I can take x common, I can factor x out, and from the last two terms I can take 3 common, so 3 times x plus 2, which is equal to 0. Then this entire x plus 2 bracket can be taken common, which is equal to 0. So this implies either the first bracket is 0 or the second bracket is 0. Since the product of two numbers is 0, this should always mean one of the number has to be 0. Now solving the first linear inequality, we get value of x is minus 2, and from the inequality and from the second equation x plus 3 is equal to 0, the value of x is minus 3. So these are my solutions of this quadratic equation. Now let's discuss our second example, our second case, when a is not equal to 1. So this is our second case, a is not equal to 1. So for example, we have 2x square plus 7x plus 3 is equal to 0. Again I want to find two numbers which add up to the middle term, and the product of two numbers m into n this should be same as the product of 2 times 3. That gives me 6. Clearly two such numbers are 6 and 1. 6 and 1 add up to 7, and the product of 6 into 1 is 6. So this implies the middle term could be written as 6x plus x plus 3 is equal to 0. Now from the first two terms, 2x could be taken common, and from the last two terms, 1 could be taken as a common number. Then this entire bracket is taken as a common factor. Now this means either the first bracket is 0, so x plus 3 is 0, or 2x plus 1 is equal to 0. Solving the first equation gives us the value of x is minus 3, and from the second equation I can take 1 to the other side, so it will become minus 1. Then this 2 could be taken to the other side, so the value of x is minus 1 by 2. So these are my two solutions, minus 3 and 1 by 2. When factorization doesn't give you clean whole numbers, this is your signal to move to the second method, that is perfect square method. So our second method, method 2, perfect square. So this is the method Cambridge test directly. They will ask you to write something in the form a times x plus b whole square plus c, and that is exactly completing the square. So you should know this. This is very important for our Cambridge examination. So let's again start with two cases. Case 1, when a is equal to 1. So for example, we have x square plus 6x plus 2 is equal to 0. Now to make it a perfect square, the first step is take half of the middle term, take half of 6 in this case, so half of 6 is 3. Then step 2 is add and subtract 3 square in this problem, in the question. So we will get x square plus 6x plus 3 square minus 3 square plus 2 as it is equal to 0. Now if you notice, the first three terms, they make a perfect square, since the middle term is just 2 times 3 times x plus 3 square. So now we have the first three terms in the form a square plus 2ab plus b square. So this means the first three terms can be written as x plus 3 whole square minus 9 plus 2 is equal to 0. This gives us x plus 3 whole square minus 7, which is equal to 0. So this is the pattern in this question. You will take half of the middle term, square it, subtract it, and make it a perfect square. Now let's discuss the second case for this method. Case 2, when a is not equal to 1. So for example, we have 2x square plus 8x minus 3 is equal to 0. Now in this case, first of all, we have to make coefficient of x square 1 by taking 2 common. So we have 2 times x square plus 4x. We'll just keep 3 as it is outside the bracket, which is equal to 0. Now we'll apply the same method. We will take half of 4. So half of 4 is 2. So it means in the given equation inside the bracket, I will add 2 square and subtract 2 square. Minus 3 is equal to 0. So this implies 2 times The first three terms, they make a perfect square of x plus 2 whole square now. Minus 4 minus 3 outside, which is equal to 0. We will simplify this bracket. So we get 2 times x plus 2 whole square minus 8 minus 3, which is equal to 0. So this implies 2 times x plus 2 whole square minus 11, which is equal to 0. This is our final answer. So there is a very common mistake while solving this question. Students generally forget to multiply this 4 with 2 while expanding the bracket. So please keep this in mind. While expanding the bracket, 2 is multiplied with each term. Now we will discuss method 3, discriminant formula. This is one of the most powerful methods in mathematics. So method 3, the discriminant formula. So if we have a quadratic equation ax squared plus bx plus c is equal to 0, we can directly find the solution by using this formula, minus b plus minus root b square minus 4ac divided by 2a. Let's understand it using one example. For example, we have this quadratic equation x squared plus 5x plus 6 is equal to 0, as discussed in our very first example in the beginning of this lesson. So if I compare, my values of a, b and c are as follows. So if I use quadratic formula, by substituting these values in the formula, we have minus 5 plus minus 5 square is 25, minus 4 times 1 times 6 inside root divided by 2 times of 1, that is 2 only. So we get minus 5 plus minus 25 minus 24, that gives us root of 1, that is 1 only, divided by 2. So this will give us two solutions, one with plus 1 positive sign, minus 5 plus 1 by 2, that is minus 2, and the other solution is with the negative sign, negative 5 negative 1 divided by 2, that gives us negative 3. So my solutions are negative 2 and negative 3. This is a very straightforward method. Now let's get back to the question I showed you in the beginning of the video and let's solve it together. So express 2x squared plus 16x plus 5 is equal to 0 in this form. So what we can do is, the first step is take 2 common to make coefficient of x squared 1 from the first two terms. So we have 2 times x squared plus 8x plus 5 is equal to 0. Then we can take half of the middle term, half of the coefficient of x, that gives us 4. This means in the given quadratic, I need to add 4 square and subtract 4 square from the terms given inside the bracket. This implies the first 3 terms can be written as a perfect square of x plus 4 whole square, and negative 4 square is negative 16 plus 5, which is equal to 0. Now we will expand this bracket. 2 will be multiplied with each term. So 2 times x plus 4 whole square minus 32 plus 5, which is equal to 0. So this implies 2 times x plus 4 whole square minus 27 is equal to 0. So these are the 3 things to remember from this video. Factorization method, in this case we have to find two numbers. Find two numbers m and n which add up to the middle term, and the product of these two numbers is same as the product of coefficient of x square and the constant term c. Then we discussed perfect square method. So in the perfect square method, you halve the coefficient of middle term, halve the coefficient, square it, subtract it, and make it a perfect square. And if coefficient of x square is not equal to 1, then you have to take that coefficient common. Method 3, discriminant formula. That's very straightforward. So if a quadratic equation ax square plus bx plus c is equal to 0 is given to us, we can directly apply quadratic formula as minus b plus minus b square minus 4ac upon 2a. In the next video, we will cover quadratic inequalities and solving simultaneous equations. Both are direct extension of what you have learned today, and both appear in Cambridge paper 1 every year. If this video helped you, please subscribe to my channel. Every video in this series follows the exact Cambridge pattern, so you can cover the entire syllabus by watching these videos. I'll see you in the next one.